Okay, so what we're going to do right now is walk ourselves through an application of when our product and quotient rules are going to be applicable for us. You'll notice that this is just a physics problem from page 10 of your unit packet. We've been doing physics a lot lately, and generally when I've asked you a question like this in the past, I've given you access to a calculator. So you've been able to take care of your computations using that technology. Now that we have these new rules, we can actually do this by hand. So the question is posing for us here a velocity function measured in meters per second, and we're asked to determine the acceleration of the particle at 4 seconds. So what I'm recalling now is that I have this physics staircase, position, velocity, and acceleration. I've got velocity provided for me here. I need acceleration. Since I'm going down one step, that means I'll find one derivative. So I'm going to write my function again, just get myself anchored in that. And this is going to drive some of you crazy, but to find a of t, that means I need to find the derivative of the function that was provided to us. No David, no Angel, you do not have to write that down if you don't want to, but that's helpful to anchor us in the work that we're about to do. Now when I look at that, I'm realizing, well, hey, I just learned this new quotient rule. It would help if I annotated the top as high and the bottom as low and use that new cool rule that we just saw about a second ago. So a of t equals the low function, t squared plus 1, times the derivative of the high function. This is one I just want you to memorize, remember, 1 over 2 square roots of t. Minus the high function times the derivative of the low, which is 2t, all over the low function squared. There's the function, nothing to it, just applying my new rule. And then the question here was to go ahead and move forward and evaluate this function at 4 so that we can really get down into the specifics of this problem. So in slow-mo, what this means is I need to plug in a 4 everywhere that I have a t. And again, this is painful to write all of this down, especially for those of you who prefer to do mental math. No, David, you do not have to write this down. You can fast forward if you want to. But I plugged a 4 in everywhere. So here I'll do some math. 4 squared plus 1 is 17. 1 over 2 square roots of 4 is 1/4. Minus 2 times 8. All over 17 squared. From here I have 17/4 minus 16 over 1, all over 289. Common denominator up top, 17/4 minus 64/4 over 289. Combining the fractions up top, negative 47 over 4, keep it, change it, flip it, times 1 over 289. Final move here gets me negative 47 over 1,156. Check me on that 4 times 289. It's late, but I think I did that right. Only thing I need now to answer the question is units. So since I found an acceleration, I'm remembering from Miss Arkia's days, my units should be meters per second squared. Put a bow on it, and you've done your first application problem with the quotient rule. Congratulations.